Hey folks, welcome back to another video. Today we're looking at question 452, minimum number of arrows to burst balloons. The way we'll be solving this problem is by sorting the array based on the end positions of the balloons. And the reason why we do it by the end positions of the balloons is because when you want to optimize, like shoot the minimum number of arrows, the last possible point that you can choose to shoot at is the end point, right? Because it's less than or equal to. So if we sort it by the basis of in the increasing order of the end position, we just check if the next balloon starting position is overlaps with the previous balloon's end position. So that way we know that there's an overlap. So it's a pretty simple problem. So let's get right into it. The first thing we do is actually sort the array, and the array that we're sorting is points, and we basically tell how to do it given two points A and B, and the way of sorting them is by comparing the endpoints. It'll be A of 1 and B of 1. Awesome. So this will give us the array sorted in the increasing order. So let's just print this out and see if it's actually giving us what we expect. So for int p in points system.out.print print line. So this will be p of 0, and then print of p of 1, and that just returns 0 right now. Okay, so let's just run this to see if it's giving us what we need. Oh wait. Okay, let's try that again. Awesome. So we see that the array is being sorted in the increasing order of the endpoints. Once we have this, let's set it up, right? So the number of arrows that need to be thrown is at least like a minimum of 1, right? So we need it at least for 1 balloon, and the end position is let's call it previous end, would be the first point, the end position of the first point. Awesome. And here, since we are starting with we are already accounting for the first balloon here, we start off with the first index, and then I less than points not length, and you increment I. Just assign this. It's not needed, but I like adding this to be able to just access it through one array instead of saying p of I of 0, p of I of 1. So that's the reason why I like to do that. And this was points, yeah. Okay. So the next part is pretty simple actually. So if p of 0, if it is greater than the previous end, which basically means that there's a no overlap, so you would increase the number of arrows. And in the end, you would just return the number of arrows. Awesome, let's compile this. Why? Oh, wait. Or I can just, yeah. Let's try that again. Let's see what's up. Okay, output is 3, expected 2. Let's see. So we have number of arrows. We need to account for at least like the first balloon. So the previous end, we take the first point and we take the last particular the ending position here. We start with int I equals 0, I less than points out length, increment I, and then we assign this to p points of I of 0 or 1. Okay, so p of 0 is greater than previous end. We increase the number of arrows and we return the arrows. Why do we... Why is this an issue? In this case, we need 4. We know it's getting sorted as required. It's not... It has nothing to do here. Points is equal to 0 if p 0. Oh, I'm not reassigning previous end. Previous end would be equal to... It would be equal to p of 1. Okay, let's try this again. Okay, cool. The first few test cases pass. Everything else passes as well. Awesome. If you have any questions, please let me know in the comments below. Don't forget to subscribe to the channel. I would really appreciate that. Thanks so much, and I'll see you folks in the next video.